Okay, hi everybody. Let's begin. So today our webinar is on web applications. How to develop a web application based on Waziup. So this is our program here. So first of all, we'll discuss about the APIs. We did a little bit last time. Now I wanted to go a bit more large and show you the HTTP API, the MQTT API. And then we'll develop an application, some example applications. So the easiest we can go is to develop a dashboard app. It requires no programming. And just clicking on the Waziup dashboard, maybe you already tried, and you have something that looks a bit like an app. At least you have some display. You can also have some actuation. So we'll show that. And of course, in this competition, you will need to go further and develop your own web application. There are different technologies for that. We'll show some examples in HTML and JavaScript, which is the simplest. Also a Python app or a React.js application. So I don't know if you have other technologies for your applications or other requests. So you can say now what do you think, which language you want to develop your application in. Any idea? So from the competitor, so did you already think about developing the web application? Yeah, Joseph or Peter or Wamola? Yeah, the question is if you already started thinking about the web application. So for this competition, you need to develop a web application or a mobile application that will read the data from your sensors and display them in a nice way for your final users. So if it's a farming application, you need to a farming use case, you need to develop a farming application. So I wanted to hear from you if you had already started that, thinking about the design, thinking about the language, about the technology you will use for the web application. Is it clear, Martin, the question? Yeah, okay. So anyone wants to start? Bineta, Amadou? Hi, Amadou. React Native, okay. I know React.js, but not React Native. So it's for which platform? Android? Android and iOS? Okay. Okay, good. What about the others? Do you have any leads on that? Okay. What is Blazor? You can also speak if you have a microphone. Okay, you said Blazor. I don't know Blazor. Blazor. is for WebAssembly. Is it correct? Oh, wow. That's very interesting. So I saw some introduction to WebAssembly, but it would be interesting, Peter, to have a feedback from you on WebAssembly. So, as far as I know, for the others, also Peter, you can say, yeah, that's right. So, WebAssembly is basically it's a binary format, but for the web. While JavaScript is not compiled, it's interpreted. So when you have JavaScript in your browser, for example, here there is some JavaScript behind, it is in clear text. The JavaScript is in clear text. So if I open my developer tool here, I go in the HTML and I can find this JavaScript. So this is some JavaScript here, right? So the JavaScript is transmitted in clear text. So for example, yeah, I don't know if I can open that. It's transmitted in clear text. It has some advantage, but the performance is not as good if it was a binary format, like an executable format. So WebAssembly is a format that is not clear text, but it's binary, and it can be executed in a sort of virtual machine inside your browser. So you correct me if I am wrong, Peter. Yeah. So please give feedback, and that's very interesting. I'm curious to know. Okay, thanks. What about the others? Do you have any other technology? Hi, Edmond. Hi, Dean. So for the newcomers, I asked which technology do you want to use for your web application? So you need to develop a web application, right? Yeah. Hi. What is that? Mobile app. In which language? In .NET. And how do you write that? Okay. Could you write in the chat maybe? Yeah, I will Google it. Flutter. Okay. It's a mobile UI. Okay, mobile UI framework. Okay, this is something I didn't know. Thanks. And the language is Dart. Wow. Hi, Prince. So we're asking which language competitors want to use for the development of the web app. So I see, yeah, Peter wants to use Blazor, which is compiled to WebAssembly. Yeah. While Dean wants to use Flutter and Dart as a language, So I find it very interesting. Those are quite new technologies. What do you say? Yeah, exactly. We were just making some survey. Which technology you are using? Okay, perfect. All right, so let's go back to our webinar. So the program of today is to go through the APIs, right? So I wanted to show you the various APIs of the Waziup platform and also the dashboard. And I will also show you a new feature that we have, which is the actuation loop. All right. So if you go on the website, you can find the full API, which is online. Documentation, Wazi Cloud API reference. Right. And here you need to install a curl, the curl command. Right. So this is you can find it in this this documentation here. Right. And this is useful in any language. So you will use different language. It can be Dart, it can be other language, other frameworks. The way to retrieve the data will be the same. So here we will follow this this tutorial here on the Wazi Cloud. First of all there is an access control. So it's based on tokens. So the idea is to open this API. It's api.waziup.io, and you get the full API here. And you will have to get a token to perform any other request. If you can also perform requests, you can just do it right now. You click on one of the endpoints, try it out, execute, and you get the response as a JSON. Right, so this is your JSON response that we will use in our program, our web application. And I did that without the token. So that means I was considered as a guest. So here I see all the sensors. So this is a list, the devices. This is a list of devices that I see here. And those are, of course, the same device that I can see on my Waziup dashboard. So we'll reopen the dashboard. So dashboard.waziup.io. Right, so all the sensors I can see here, I can see them on the API, on the website of the API, api.waziup.io. Right, and this command now, we will perform it also with the curl. Curl is a tool for performing HTTP commands. I was telling to you that you also need to retrieve a token. So this one here. So you input in the fields your username and your password, okay, and then you click on execute, and you will get this big number here. And this is a web token, JavaScript web token. So I pick up this big number here, and I will put it in the little lock here, right? I need to write bearer space, and I pass the token, right? So remember about this bearer. space, and the token I was given earlier. Authorize, close. And now the requests I will make, the platform will identify me, right? So, okay, I will get sensors that are also mine and private. I could not see them before, right? Now let's do this also with the curl command, and then we'll try in HTML and in Python. Okay, I come back on the API reference, right? And I use a curl. Right, so the idea is to copy those comments like that. Open a terminal. You can have this also on Windows. I pass the command here and I get the token. You see the number is my token. Right. So we'll use that for making successive comments, and just to show you how it will work also inside your application. So I scroll a bit down. I will just show you taking one, for example, read the list of device. Right. So I copy this command here, and it's a get. It's an HTTP get. This is the address of my devices, and this is the header here. So I get this one. And I get the list of sensors. There are so many that it's not really readable. So for that, I install another command which is called JQ, like this, JQ. It's in the tutorial. And with, let me reset the screen. So this curl command here gives a lot of JSON. I will need to pipe it. So vertical, you see this character here. It's called a pipe. So vertical pipe is vertical bar. It's a pipe which will take the output of this command and feed it to whatever I write after, to another command called JQ. So I pipe it to JQ, and I will get a nice display of JSON. Same data, right, but nicer. And here are all my devices. All right. So let me come back a little bit on the HTTP. So I need to find it again. Okay, just to summarize. So in the HTTP, there are those four methods that you know. Post, to create something. Put, to modify something. Get, to get something. And delete, to delete something. This something will be located at a URL, right, like that. In Waziup, I'm coming back on my reference here. Sorry, this one, yeah. So everything at the URL, right? Your devices have a URL like that. So the slash devices slash the ID of your device. And sensors that you will plug on your device also have a URL constructed like this, because a sensor is always plugged on a device. A device is an Arduino, right? A sensor is a DHT, for example, DHT sensor. So you construct your URL like this one. So the idea that you need to perform the HTTP request using a method to get a URL, which is the path of your resource, and the various number of headers, right? So all those headers, there are some often a bit ignored by the users or misunderstood. There are two main that are important. the accept and the content type. So I will show you also in the API here, the API website. You can see that sometimes you can, in a get here, I can specify the content type. Yeah, let me show you the curl command also. Logout, close. And if I want to create a resource, I can use a post. And I can specify both the content type and the response content type. So I will execute that and copy the post. Yeah, the post looked like that. I will just copy the initial part. So you can see that in this request here, it is a request containing a post. I will copy it in full, why not? Right, you can see it, right? So it's a bit cryptic here, but the idea that you mention in your command what method you want. Here I want to post. Then you mention the path. I want to post what? A device, because I am on the path of devices here. And then you mention here the last part is the data. This is my sensor. Okay, I mentioned the ID of that sensor and different parameters like the name of that sensor of that or that device. And there are two more parameters which are called headers -h, and the most common are accept and content type. Basically, accept, I am telling the server that, or let's take content type. So for content type, I am telling the server, I am sending to him what? Something in JSON, right? The content type will be JSON. So this data here is JSON, right? That's what I'm telling. It could be something else. I could also write application XML or text, right? Plain text. So this content type here means what I am sending, while the other one, the accept, means what I am expecting as a response, right? So I am accepting some data back and I want it in this format. So if the server will read this accept here, and if I write JSON, will send me back the JSON. It could be a get, for example. So if I'm getting something, I can say get something and I write the accept JSON. Could write accept text. You see what I mean? So this is what you expect. All right. So last part of the request is also the what is called this the query, sorry, the query. So let me show you that. So for instance, here I want to query some devices and to filter them. And here in the website you can filter them. For example, I want to say I want maximum 10, right? And the syntax will be like that in the, you see here in the curl command. This is a query list. So it's part of the HTTP protocol. Right, so here I am getting devices and I am specifying the limits. So this is my query string here. Limit will be 10, and if it starts with a question mark. But if I want to put several more, I can also use this commercial and here and continue my query list. For example, I want offset is 10. So here I want not the first 10 but next 10. So the device from the 10 to 20, right? Device number 10 to device number 20. This is what is said here. So this is pretty much all. So I want to briefly recap this. Yeah, also the response code is important. Most of you know them, right? So what is the most common response code? It's 404, right? 404 is a response code we get quite often when we go on internet. 200 is successful. 300 is a redirection, so the page is not here, but you can go there, right? And 400 and 500 are error codes. So 400, it means that you made an error. The server is telling you made an error in your request. While 500, it means I made an error. As a server, I made a mistake. And this is usually a programming mistake, so this is a big error. All the 500s. 400 is easy to get if you make a mistake in your requests. So, for example, yeah, this one, you see it works. But if I make a mistake somewhere, for example, I remove here, I will get this error. I need to add -v for verbose, and I get the error 404. What I requested is not here, because here I make a spelling mistake, right? Uses typo. Devices is without the I. All right. Okay, let me show you now a little bit of MQTT. Right. So in the same tutorial, toward the end, there is a part on MQTT. Right, how to publish, and how to subscribe. Now let me show you also a short introduction on the MQTT. So, you know, HTTP is a protocol which is a client server. That is, it is a request response. So I request a data from a server, and it gives me back, and then after that it forgets about me, right? It's very efficient. HTTP is a very widespread protocol, and it is very used and very efficient. But in the case of IoT, there is a problem. So do you know what is this problem? Why I cannot use HTTP for IoT? Any idea? So there is a problem with the model of HTTP, is that if it's a request response, that means I will have to query my sensor very often, and maybe this sensor has some updates, maybe not. So I will be obliged to do something called a polling. That is, I will ask my sensor, do you have any new value? Sensor will be say, no, I don't have. Then 1 minute after or 10 seconds after, I come back, do you have some new value? No. And like that all the time. So this is not very efficient, right? This technique of polling, that is asking very often, do you have novelties for me, is not efficient. So we come up with a new protocol called MQTT, and a family of protocol actually, which are called publish, subscribe. So HTTP is a request response. MQTT is publish, subscribe. So instead of asking all the time, do you have an update to my sensor, I will reverse the control. I will give the sensor or the device the control. I will say to him, look, I am interested in this data. If you have something new, you can call me back, right? And that's publish, subscribe. So I will subscribe on the data I am interested in. Yes, so this is the difference here. Yeah. So the This is the basic difference between HTTP that I use every day. I use it here, you see, on my browser. I use the get to get this page. With MQTT, it's the opposite. I give the control to the server and it will call me back. So the difference is that in HTTP, we have get, post, put, patch, delete. Okay, patch is a new one, a new verb. All those verbs are oriented toward a request response, right? I request with get and it will give me back. With MQTT, the key here is the subscribe. I am subscribing on some piece of information I am interested in. It's also a big difference is a connected protocol. So when I will subscribe on something, I will stay online. I will stay connected to that server, right? And if there is some updates, it will call me. So it's a connected protocol, while HTTP is not connected. In the sense that once you are making your request, you disconnect. Right, and the idea with the MQTT that there is a central broker which is managing the connections and keeping the last data. So if I have a client like a server pushing some data to that broker, the broker will wake up the clients that was subscribed there. Right, so the sensor will just push the data and then go back to sleep. Nobody will disturb him, and that's the broker that will do the job of informing the other clients about the novelty, right? About what happens with this sensor. Okay, let's make a try. Let's try it. So you need to install this Mosquito pub and Mosquito sub. Those are clients for HTTP. The link is here. It's on the website. Waziup.io. So you install this client here, and you can start publishing and subscribing on the Waziup platform. So it's free to use. You can do that. Let's copy that and try it. Okay, so here I will try to publish. It looks a bit like HTTP, right? This URL here. The only difference is that you have here a MQTT instead of HTTP. And this here is called a topic. This is not a URL. It's not a URL, it's a topic. And here I want to publish on that topic. It works the same way than the URL, right? So I will publish a value of 3 on a device, and on that device on a sensor. So my device is my device, sensor is TC1. So let's look at this one on the dashboard. I can do different ways to find it. Either flip on public resources and filter somehow. Might not be super easy. I might have a lot. It's called my device. Okay, not this one. Too many are starting by my device. Another way is to just add it here in the URL, like that. Okay, so here I am a. Let's rename it. This one. Okay. Device is my device. Sensor is TC1. I will publish on this one. So you can see that I am publishing with Mosquito on my device. It's my device here. And the sensor is TC1. It's TC1 here. Here it is. So it should have worked. Let's refresh that. Yeah, 3. 3 is come here. Right. Now let's do the opposite. So I will register on that device and sensor. I will subscribe, sorry. So I'm coming back on my API reference and I will do the subscribe here. Right, subscribe. So this is Mosquito sub this time. This one was Mosquito pub, like publish, sub like subscribe. I'm subscribing on the same. So you see that now I am blocked. My terminal is blocked. I cannot use it because it is subscribed. And as I said before, it is a connected protocol. So now I am connected to that device. And any change that I will do on my device, here, my guy here will be informed. So let's update it. Let's do something. So I will come back on my Swagger here and I will publish a message. Or yeah, let's do through the Swagger. So I will select an endpoint that is able to push some value on my sensor. This is the one post on the value. Device ID is my device. Sensor ID is TC1. All right, I will push this value 25. Execute. Right, the code is 204, which is positive. So everything that starts with 200 is good. I come back on the sensor, I refresh, it's 25. Let's see if my MQTT subscription worked. Come back here, yes. You can see that in my channel that I open here, I received also the value. And the idea is that here I'm doing it with the terminal, you know, but you need to do that with your application as well. So let's finish that. All right, so let's come back to the MQTT here PDF. So okay, MQTT has quality of service. So there are 3 levels of quality of service, right? Fire and forget. So basically the clients will send message to the broker, but not check any of the results. Deliver at least once and deliver exactly once. Yeah, so basically that's what it says. Yeah, so fire and forget, of course, is lighter because you would just send one message. While with the 2 others, of course, there is a protocol or some communication that will happen between the client and the broker to make sure that your message arrived at least once or exactly once. Last will testament is important also, in that the sense that with the IoT, you are never sure, it's not very reliable. Your sensors might die at any moment. So this sensor was sending data and suddenly it dies without giving you any news. So you want to configure the broker to do something in case you are dying. So basically this is the last will testament. So you will just mention, for example, some system will be safer in some position if one of your component dies. So you will instruct the broker, okay, if I am dying, go into this state and inform the others, right? So this is a way to specify what to do if you're not sending any more message and you are considered as dead as a sensor. So this is the last will. Right, it is working as sessions, we saw that, and it is like HTTP. Here I am using HTTPS, like secured. It is encrypted communication based on SSL. MQTT does the same, so there is MQTT-S as a protocol, which is also just a channel encrypted with SSL. All right. So you can see that the response time is lower with MQTT than HTTP, right? And it has lower battery use. I will share with you those slides. And MQTT is much lighter than HTTP. HTTP has so many headers and details, while MQTT is very simple. Okay. So now we will see how to use this API in various scenarios. So the first thing that you can do. Hello. Hi Peter, could you mute maybe your microphone? Okay. So when you want to develop a web app, in Waziup you will start with the dashboard. So I guess at this point you are already a bit familiar with this dashboard. The idea is that you start with the devices. So I have already plenty of devices, but if I will try another account, be simpler. Yeah, here I am logged in with an account called Waziup. Here I don't have any device, right? And there are two ways. Either you have the Waziup gateway already configured, and in this case you don't need to do anything because the Waziup gateway will create the device for you. So your device will appear here once you have this gateway configured. They will appear here, right? You don't have to do it. However, in some of the use case, for example, you don't have a Waziup gateway, or you want to use it, use the dashboard directly using the API, you can create them manually, right? So for that, you go in the settings, and you will do allow manual creation of gateways and devices. Yeah, you come back on devices, and then you see this button here appear. Add a device, and then you can create the device. Yes. So let's create a new device. Submit. Since device created, come here. I go in, and then I can add some sensors. For example, this one, default one is okay. It goes here, and here you already see the address of that sensor. Yeah. And using the API, as we see, we have seen, you are able to use it. So you can also create actuators. In the last webinar, I already showed that. How to create actuators, how to use them. Now we show you something very interesting. You can create an actuation loop within Waziup. So this is a feature that we'll publish soon. It's already available on the private dashboard here called staging. This one. Okay, so yeah, let me log into my normal account. So here, for example, I have a device, right? And on this device, I have a sensor and a motor, right? And I want to connect them. The idea that, for example, if this is a temperature here, will rise over a limit, something will happen with the motor. For example, this is a fan that will switch on, right? So I can use a feature called notifications that you can see here for that. So I go on my sensor here and I click on add notification, right? And here I have a panel with the condition and the action. So I have two kinds of actions. The first is to send a message on social networks, and the second is to create an actuation. I will select actuation now. So let's come back on the condition. So condition action. My condition here, I need to configure it, and I select my device. So it is already my device 89, the one we are using now. I select my sensor. Okay, there are two sensors here. I select this one, the one I was also viewing. Sorry. And then I will select an expression. So expression is a simple language to create the condition. Here it's very simple to understand, right? My sensor here that I selected, TC, is more than 30 degrees. So if that happens, then I will trigger the action. So let's try. So I will put a bit more, 70. Now we are at 60 degrees. So if the temperature will be more than 70 degrees, do something. Actuate. And actuate something. So what? I will actuate a motor, which is on the same device. It could be different, but this is the same device. So I selected the only actuator that was configured. It's called mot, and send a value. And for example, I will send this value. I will send alert. Okay, the value is JSON, so it could be a sentence. Depends on the kind of actuator you have, right? So in this case, it's a fan. So it could be, you could write true. That means switch on the fan, right? And you can also write a message. So for example, you could write alert temperature too high. And in your message, you could write also you can use this templated system. So here $TC, written like that, it will insert the current value. For example, the current value of my TC here, it's 60 degrees, it's 60. The value is 60, so I can use it here. So this actuation here, you can write it at this JSON value here. It's a sentence, but it could be also just a number, like 20. It could be a boolean, like true, false, if you want to switch on something, off something, right? And it can be also this TC, like that, which is the value of the temperature. So let's try like that. So I submit that. Okay, my notification is created, is here at the bottom. So we can review it. So it is my sensor is TC. TC will be more than 70 degrees. In this case, the motor will okay, it's not really for a motor. This will be a display. It will write this one. Let's try it. Okay, I'm coming back on my device here. Temperature sensor. All right. At the bottom of the screen, we are adding also a testing zone. It's a new feature, so it's not available on the main dashboard now. But it will be very soon, in some days. I can push a value on this sensor just for testing, right? That's why it's called testing zone. So instead of doing it with the real device, here I am just testing with the dashboard. So I will send the value 80. Submit. Right. So look, my sensor here is now 80 degrees. So this should be triggered, right? TC more than 70, it should be triggered. Let's check. Yes, it says that the actuation was sent once. So let's control it. So I come back on my device, and I see my motor here did something, right? So that's the actuation loop. So any questions on that? So you, of course, this will go back to the Arduino. Is it clear? All right. So we can try it also live. So you see here also it was displayed here. It's another experiment, of course, it's not the same. But here the actuation loop was working. So here I have a temperature sensor on my Arduino. What's the dev is here, and I start also the Arduino, so we have the full chain. So here I have an Arduino code, right? I flash this one. Not sure it's working. So it's flashing. Okay, done. It is now starting. Sending. Okay, receive. A bit of refresh here. Okay, I see my value here, 45.7. Is it correct? That's what I have here. Yeah. And this now I will look it also on the. This is a gateway, right? I am on the local gateway, but I will look it on the cloud also. So I pick up the ID of the device, and I will acquire it also. I put the ID here. Here I have it here. Okay. Okay, and I will create the notification for this sensor. So I click on Add Notification. If the sensor is more than 30 degrees, I can send a different social network. I don't know if you tried this one, Twitter, SMS, and voice, but also some actuation. So actuation. Okay, this is the code for my actuator, the one I have on the gateway. This actuator here. Okay, here the IDs are quite big. And I select this device, this actuator, and the value here. Right. Okay, let's put it like that. Right, so I'm programming some notification here. Submit. Okay. So my notification is coming up here, and I see that the temperature sensor is more than 30. It is already the case. So that means that I should receive an alert now, because it's already the condition is already respected, and I see it here, right? And it should also come back at the device level. So the payload is here. Yeah, you can see, right? So it works. So if I change this value here, payload should change also. Upload. So here I've just shown you as a complete loop device to gateway, to cloud, and back. So I program on the cloud a notification, what we call an actuation loop. And here I am sending a value with my Arduino. Right, so it's sending the value. This value goes through the gateway. So 49.7, that's my update. It's a new sensor value. And it arrives on the cloud. It didn't arrive here, I don't know. Maybe it was not configured correctly. Yeah, it is arriving on the cloud, and then I program this notification to send back an actuation. So if something happens, so it's one way for having, let's say, simple, let's say, control on your use case or application. If you don't want to program anything more, right? So you can do it with the dashboard. So this feature, this actuation loop, will be available in a couple of days. We just need to test it now. Okay, so let's move forward. So now we did those first three. So I explained to you how to create an application on the dashboard. So now the principle is that dashboard will not be enough, right? If you want to create a nice business-oriented application, there is too much information on the dashboard. It's not for the final users. So you need to create your own application, right? And for that, we created some examples that you can reuse in HTML, JavaScript, and Python. I will show you them now. And also the dashboard, this dashboard here is written in JavaScript. All right, it's quite complex dashboard, but the source is open source, so you can also use it and restart from it. All right, let me show you the HTML. So you go on the documentation, Waziup Cloud, create your web app. And here there is a short tutorial how to fork the templates of the web app. So here I click here, and those are the templates, and they are running. They are running on GitHub. By running, I mean they are rendered, and because GitHub offers a service called GitHub Pages to show simple applications that doesn't need a database. And that's our case because our database will be Waziup. So we will use the API of Waziup to create our application. So there are different examples. The simplest is this one: retrieve a single device. And here, this is my two-line application. I retrieved in HTML the value of a sensor. It's a real sensor, live, with this value. I'll show you the code now. So the code is here. Simple. Index.html. And this is my application. It's really short as possible, right? It's 22 lines. You recognize the HTML body and script, and so here I am using a library. So this is including the library. This library is called waziup.js. It is available on the GitHub. So yeah, just find it. I think if you go on Waziup Cloud, you find it here. Okay, waziup.js, And here you have all the documentation how to use this library. Anyway, it's very simple. So you instantiate the API and then you use it to get some data. You give the ID of your device, the ID of your sensor. You know, it's always device and then sensor. And then you get the value and you work it a little bit to display it, right? And that's the result we saw. There are other examples to create a graph, to create a map, and a more complex application, which are a little bit more involved. For the different results, you can see them here. So this is the graph. It's a real time. Oh, it's a bit old actually. But those are real values. Maybe the sensor is switched off. And here the map. So we get to wait that is loading. I don't know why the map is not loading. Okay, I need to check. All right, so here in this repository you get the different examples. Simplest way to go, right? And if you want to develop your application in React Native, you can reuse this library. So that's what I did in the dashboard. So if you go in Waziup Cloud, yeah, you get a link to the dashboard. Let's switch back to master. So this is the dashboard here of the Waziup, the source, open source. And in the package.json, I have a link to my waziup.js, right? So this library here is a wrapper over the API that we used before, right? So in React Native, you can do the same, right? And with the other framework we discussed before, like Flutter, you can also do that. So they all support HTTP or MQTT APIs, no problem. All right, there is also a small example on Python in the same in the folder I showed you before. So let's find it back. Python here. Right, just to show you, there are some extraction here, how to use MQTT in Python, right? So it's quite simple. Here we are using a client called Paho MQTT client, and you have the function for subscribing. We subscribe on a device and a sensor in that device, and the value change for that device. So this is the topic we discussed before, and I'm subscribing on that, right? And then I will loop, waiting new values coming. And when there will be a new value, I will print this message. Right, so this is really super simple. Let me see if I can try it. So let's try the MQTT one. Yeah, it is connected now. And I will of course push some data, right? I need to check the exact name of the device. So my device TC1. Okay, I will push data on this one. Same than before, so I will select the endpoint for pushing data. This is the one, so post device sensor 25, execute. Oops, forbidden now. I put in private before. So now I definitely need to switch back to public. So for switching back to public, I need to use the token. No, I can also do that on the dashboard, sorry. Okay, it's private, you see. So I put it back to public. Okay, now public. That means I will be able to push the data. Okay, 204 is positive. And here I get the new value, right, in my Python application. So that's how you get data from the Waziup platform in Python. Any question? Right? Became a bit complicated or confused. So in this, I think this concludes our webinar actually, because we went through all the topics. So I showed you how to interact with Waziup with HTTP, also with MQTT, right? The two major protocols now. One is request response, the other is publish subscribe. I showed you the dashboard of Waziup, how you can create devices, you can create sensors, you can create actuators, and you can create a loop between sensing and actuating using the notifications. Next, we saw the HTML and JavaScript applications that you can develop using a library that you find on the GitHub, right? And you can do that also with Python, interacting with the MQTT in our case, and with React.js, right? If you want to look at the Waziup dashboard, it is made in React.js. All right. Yeah. Okay. So thanks everyone, and talk next week.